I've got a couple of problems here that, number one, I'd like you to do this one over here, pause the video and do this one. So, in other words, this is from Homework 6 worksheet number 1A, where you're supposed to use the definition of the derivative to find f prime. I know you know that this is 6x minus 2 using the rules that you learned last year, but I want you to use the definition of the derivative to find that. Okay, so the way we're going to do that is we're going to let f prime of x, we're going to write down the difference quotient using limits here. Limit as h goes to 0 of the difference quotient, just like we just talked about in the last video. Okay, and then we're going to replace f of x plus h, noticing here that f of x is given, so everywhere we see an x, we're going to replace that with x plus h. So we're going to figure out what that is, and f of x plus h would be, I should probably do that somewhere else. Let me do that right off here to this, right over here to the side. F of x plus h is equal to 3 times x plus h squared minus 2 times x plus h. So if you can get that down, we're going to keep this in mind, and we're going to replace f of x plus h with this expression right there. Okay? So we're going to put that, so this is the equal sign comes down here. This is just side work over here. Just pretend there's a wall there. This is not equal to this over here. So hopefully you get that figured out. Anyway, we've got f of x plus h, which is 3 times the quantity x plus h squared minus 2 times the quantity x plus h, and we're subtracting from that, it says up here, f of x, and so we already know what that is. That's 3x squared minus 2x. Well, that's all over h, and let's not forget about that limit. Been teaching pre-calc honors, and we aren't dealing with limits yet, so we're doing this exact same thing. Here we are in September doing this exact same problem without the limits. So if you go ahead and simplify this numerator, what you get is 3 times this quantity. Okay, well 3 times the quantity is x squared plus 2xh plus h squared minus 2x minus 2h, going over my allotted space here, minus 3x squared plus 2x. Don't forget to distribute that minus sign. Okay, so we're going to have to keep going down here. Equals the limit, and when you do this problem, these kinds of problems, I want you to make sure you keep writing that limit. 3x squared, so we're distributing the 3, plus 6xh plus 3h squared minus 2x minus 2h. Okay, and this whole thing here, all over h. And finally, we get to cancel some terms in this numerator that don't have an h in them. 3x squared, I know that's going to cancel with something that's over there. And then any other term that doesn't have an h in it, oh, there's one. Negative 2x, that's got to have a partner. That's the positive 2x over there, so those cancel each other out. And then we get, if we can do this all at the same time, I'm going to factor out an h from all the terms that are left over, so I get to cancel that h in the denominator. And then when I factor out an h from this 6xh, I get 6x. Factoring out an h from the next term, it leaves me with 3h. And then finally, minus 2 after taking the h out of that term. Canceling with that h in the denominator leaves us with this expression. Now, we have an expression here, and this is where sometimes students get kind of freaked out. They don't know what to do. But what we have here is the limit. Let's just turn it into a limit problem. Let's not get too hasty here. Limit of 6x plus 3h minus 2 as h goes to 0. So we have this expression. We're going to let h go to 0. Well, what does that mean? It means that this term right here, 3 times h, if h goes to 0, well, that term is going to 0. And if that term is going to 0, what we're left with is not the limit of 6x minus 2, it's just 6x minus 2. What is the intended value of this function when h goes to 0? Well, the intended value is 6x minus 2. Well, we knew that already, like we talked about in the beginning. Okay? Let me show you one more. problem number 7, this was not intended for you to be doing this after pausing the video, but if you want to go for it without seeing how to do this, go ahead. Maybe you can remember how to do this from last year. This problem here is more like what you're going to see on an AP exam. It's going to say, evaluate this. Well, you certainly don't want to try to do anything like factoring out and e squared and anything like that, e to the h minus 1. You don't need to do that. You could if you remembered those limits, but this is an expression that actually if you back up you can get to. Let me see if I can show you this at the same time. So if you look at this expression here, it looks an awful lot like one of these expressions way over here. Okay? So this is what I want to help you see. If I can help you see this, this would be great, because you're going to see these kinds of problems on practice AP exams and then probably the real thing as well. So we've got this expression. Notice that we have a limit as h goes to 0, and that means that we're eliminating this, the third choice right off the bat. We're eliminating that right off the bat because it's, here we have x approaches a, here we have h approaches 0. And then we don't have any x's in there. Okay, so that means we're eliminating the first one. That means we've got one left. Notice that we have h approaching 0, good, f of something. So we have some function of a plus h. Now a is a real number, and so notice that the 2 here is the a here, same position. Okay, so what we want to know here is, what is the function? Well, f of a is f of 2. So if we back up here, e squared represents f of 2. Okay? Well, e to the 2 plus h represents f of 2 plus h. Well, we should recognize here that e to the x then would be f of x. Okay, so we're getting, oops, not seeing that. So we're getting somewhere. If e squared is f of 2, e to the 2, so e to the x is f of x. So this is our function. Well, what did we say back up here? Well, the function says, like this whole expression here says f prime at a. Well, this sometimes takes a little while to really understand what's going on, but I urge you to try to dig deep here and see if you can really see it. So we've determined that our f of x is e to the x. What we also should realize is that this guy right here is f prime at 2. And if this is f prime at 2, and f of x is e squared, then we can easily figure out that f prime of x, we know that the derivative of e to the x is e to the x. So f prime of x is e to the x, that means that f prime of 2 is e squared. Well, if this thing is f prime of 2, and we're trying to figure out what f prime of 2 is, we just figured it out. Whoa. We just figured it out. E squared. That's it.